Algebra 2 students, we are going to learn a skill today that will force any quadratic trinomial to factor. But it doesn't always make it factor nice. It just makes it possible to isolate the x with the square root. So let's take this problem we've seen before, a simple one. X squared equals 9. You can solve for x because you can just take the square root of both sides and get x equals plus or minus 3. Then we had this problem, x squared plus 5x plus 6 equals 0. And we could solve this because we knew there were factors of 6 that added to 5. And we could factor this to x plus 3 times x plus 2. And then we could say x plus 2 equals 0, x equals negative 2. Or we could say x plus 3 equals 0, x equals negative 3. Well, what are we going to do if it's x squared plus 10x plus 6 equals 0? Some of you might be saying, oh, well, you can use the quadratic formula. Well, what we're about to learn today is how you produce the quadratic formula, because the quadratic formula is not magic. It just does some math all in one step that you're going to learn all the multiple steps for. So there are no factors of 6 that add to 10. We can't isolate x squared and take the square root. So we are going to force this to become a square so we can do this. So that we can isolate x as a square. And it's based on those special forms that you looked at last week. If I think of a squared plus 2ab plus b squared, I know that that's going to factor to a plus b quantity squared. And then if I was trying to solve for a, I could take the square root of this because I have this whole thing squared. So the way this problem works, let me clear the screen. The way this problem works, x squared plus 10x plus 6 equals 0. Because it's a little bit more, it's tougher when it's not an equation. If I think of this as a squared and then I think of this as plus 2ab, what's missing is the b squared. I have this plus 6, but that's not what I need. I need something else here, plus b squared. So this process is called completing the square. So if I look at this as a squared, it's pretty easy to see that a equals x. And if I look at this as 2ab, then it's pretty easy to see, since we know a is x, that 2b is equal to 10. So what's b? 5. And so what has to go here is a b squared. So what I need to do is I need to add 25. Now you can't just add 25 to one side without adding it to the other, right? And I don't really need to add 25, I just need to add something that gets this to be 25. So what I'm going to do is I'm actually just going to add 19. So now I have this, x squared plus 10x plus 6 plus 19, which is plus 25, and that equals 19. Now earlier we were talking about how we wanted our quadratics to equal 0, but that's because we were using the fact that two things multiply to get 0, one of them has to be 0. What we're doing now is we're saying something squared is 19, and that's perfectly fine. X plus 5 quantity squared is 19. So what we know is that x plus 5 has to equal plus or minus the square root of 19. And now we can solve for x and get x is equal to negative 5 plus or minus the square root of 19. So we were able to solve this quadratic up here in the blue that didn't factor by a process that is called completing the square. It's called completing the square because you assume you have the first part of those special forms we were looking at, and you're trying to complete the square by finding the number that you have to add to make it a square. Now, in the next slide here, I'll give you the step-by-step rules, but I want you to watch this slide again because here I'm talking about the idea of how it works. Not just the do this, X, not just the steps of it, but actually why does it work? If you use your brain, how could you think through this process? How could you find the number B that's missing that would make this a complete square? So let's try another example. Another example, let's say x squared minus 8x plus 15 equals 0. Uh-oh, that doesn't work. Don't you love that? There are factors of 15 that add to 8. So let's do 16. Okay. Are there factors of 16 that add to 4? Yes, there are. Let's do 17. Okay, not a nice number. 17. Sorry about that. So what I was finding there was I'm making these numbers up on my own. If factors factor, it's a much easier process to solve a quadratic. So what most people will do when they solve this by completing the square is they will take the 17 and they'll throw it to the other side. So they have this minus 17 over here. Now they have this empty space where they have to figure out what to complete the square with. So the first step is take the coefficient of x. As long as this is an x squared, take the coefficient of x and divide by 2. The reason for that is if we're saying it's ax squared minus 2ab, we know a is equal to x. So we know this term here is equal to 2 times a times b, or 2 times x times b. And if I set that equal to 8, then you can 8x. You can see that the x's cancel. And so some kids memorize take half of this number. But do you see why you take half of this number? To solve for b, you would just divide by 2. So you take half of that number. Half of that number is 4. And you square that. That's what needs to be added here is 16. And that's what needs to be added here, which is 16. Now I get x squared minus 8x plus 16 equals negative 1. Now I know this factors to x minus 4 quantity squared, which equals negative 1. Then you get x minus 4 equals plus or minus the square root of negative 1. And so you get x equals 4 plus or minus the square root of negative 1, which some of you might know as I. Again, making an example up off the top of my head. We're not really quite ready for that, but we will talk about this imaginary unit, so don't worry about it. But the idea that you can isolate something and take the square root of it. Let's do another example. This time I'm going to pause the video so I can come up with a good example. All right, here we go. 4x squared plus 16x plus, let's say, 8 equals 0. This may not be the best example, but I'm going to go ahead and just do it. So looking here, everything has a 4, and it's so much easier if you can get rid of this 4 to complete the square. So that's what I'm going to do. I'm going to divide everything by 4, and I can do that because it's an equation. Actually, with this one, let's not do an equation. Let's just an expression. So now we're going to be stuck doing a little more tough work. So I'm going to factor out a 4, but just from the terms with the x, and I'm going to leave the 8 out here. Now inside the parenthesis here, I'm going to complete the square. What's half of 4? 2. What's 2 squared? That's 4. So I need to add 4 to complete the square, but be careful. I really didn't add 4, I added 16. Because this is an expression, I can't add 16 on the other side, So what I have to do is I have to subtract 16 on the same side. So that right there, that's a little tricky, right? I added 4 inside a parenthesis that was being multiplied by 4. You can't take a number and just add 4 to it. You'll change its value, so you have to subtract 4 in the same step. 2 plus 4 minus 4 is still 2. In this case, I didn't really add 4, I added 16, so I had to subtract 16 out here. Now, kind of creatively collecting like terms, I'm going to call this x plus 2 quantity squared. That was the whole reason I did that. I wanted to complete the square. And now I'm going to collect these like terms and get minus 8. And there you go. Now I've taken this expression and it's equal to this one here. They just look different. Good? All right. One last example that's really messy because you kids hate messy and I don't mind messy. So I'm going to make this one up. It is not going to be nice intentionally. Let's say 3x squared minus, I'm not going to be nice, minus 15x plus 2 equals 0. Are there factors of 3 that combine with factors of 2 to have a sum of 15? And the answer is no. So if you were going to solve this, you do not know the quadratic formula yet. I do not want you using that. You're going to have to complete the square. So here's what I do. I take that 2 and I throw it over to the other side because it's just going to get in my way. Then I divide everything by 3. I was a little nice by giving you something divisible by 3, but over here I did not, and I don't care. I think that's fine. Now what I'm going to do is I'm going to take half of 5, and here's where it's going to get gross. Half of 5 is 5 halves and not 2.5. It is 2.5, but do not use 2.5. Half of 5 is 5 halves. I square 5 halves. That's 25 fourths. I can't just add 25 fourths here unless I add 25 fourths over here. When I do that, I now have x minus 5 halves quantity squared equals negative 2/3 plus 25 fourths. So I multiply that by 4 over 4. I get negative 8 over 12. I multiply this by 3 over 3. I get 75 over 12. 75 minus 8. That's going to equal, you probably beat me to it, 67 over 12. Good, I'm now going to take the square root of both sides. I'm running out of room, so I'm going to write this on the next slide. X minus 5 halves quantity squared equals 67 twelfths. Okay, so x minus 5 halves quantity squared equals 67 twelfths. Take square root of both sides. X minus 5 halves equals the plus or minus the square root. I'm going to do this over here, simplify a little bit. Over square root of 67, can't speak. Square root of 67 over 12. That's the square root of 67 divided by 2 root 3. So that's multiplied by root 3 over root 3. So I get this nice rational denominator. 2 times root 3 is 6, and 67 times the square root of 3 is 21 plus 180, so that is the square root of 201. Good. Now I add 5 halves to both sides, and I get x is 5 halves plus or minus the square root of 201 over 6. Or, if I wanted, I could say 15 plus or minus the square root of 201 over 6. Be prepared for some problems like that last example in classwork. Because I don't want you to always have nice numbers, and I want you to get this skill, right? So if we go through the steps one last time, write these down. The steps are, get x squared, get the ax squared plus bx by itself. Whether you do that by factoring and grouping it together, or if it's an equation and you throw the c to the other side. Then if there is an a value that's not 1, you got to get rid of a. So divide by a, or factor out depending on what you have. If you have an equation, you can divide by a, but if you don't have an equation, you have to factor out an a. Then once you do that, you look at the coefficient. The coefficient of the x term. And you want to take half of that. That's the number that you are going to square and add to both sides or subtract, or sorry, add to both sides or add and subtract on the same side. So then add that number from step, 1, 2, 3, 4. Add that number from step 3 squared to, or add that number and then subtract, right? Add to both sides or add and subtract. And then it's all after that. It's factoring. So it's a completed square, an a minus b quantity squared, right? Okay, watch that video again. That's a pretty difficult concept, but it's a huge skill. And it's a skill that like creeps up on you, and you use it out of nowhere in pre-cal, and I love it because people are like, oh my gosh, we have to remember how to complete the square. Because once we complete the square a lot, we use it to create the quadratic formula. And then once we create the quadratic formula, we use that because it's faster, and we know how it works, and it just is done. But as most kids do, once they get the shortcut, they forget the real deal. Holyfield. All right. Have a good night. Peace.